And here is question number 14 of WAEC 2025 further mathematics examination, the theory questions. And question number 14a reads, 5 forces acting on a particle are represented by these 5 vectors, 1, 2, 3, 4, and 5, where P and Q are all real numbers. If the particle is in equilibrium, find the values of P and Q. You can see them in the last vector. Before we start solving, I would like to explain something. Let's assume we have a particle right here, and 2 forces acted on this particle. Whether they are pushing or pulling the particle, it doesn't matter. We have maybe force A, let me call it F1, and F2. These are 2 forces that acted on this particle. Provided the particle remain in equilibrium, it means it has not shifted. It implies that the resultant force is equal to 0. Yes, which implies the moment you add the 2 forces together, you're going to get 0. The same thing is happening here. All right. You see, in this situation, we have 2 components, components I and J. Both will be equal to 0. So let's start with I component. If you take, this is very simple to solve, 2I plus 4I, plus and minus will give us minus 5I, then plus I, lastly plus Pi. All of this will give us 0I. You should know that. So let's solve this one first. 2 plus 4 is 6, and 6 minus 5 is 1, plus 1 is 2. So we have 2I plus Pi equal to 0I. You may take this one to the other side, which implies that Pi is equal to 0I minus 2I, which is going to give us negative 2I here, right? Pi is equal to negative 2I, but remember, we are looking for P. P must be negative 2. Therefore, P is equal to negative 2. Let's do the same thing for J component. We have 3J minus 7J plus 8J plus J plus QJ. This must be 0J, right? 3 minus 7 will give us negative 4. Negative 4 plus 8 will give us positive 4, plus 1 is 5. So we have 5J plus QJ equal to 0J. QJ is equal to 0J minus 5J as this crosses over. QJ is equal to negative 5J. And this implies that Q is equal to negative 5. So we can conclude that if you like, we can bring them together, but it is not necessary. You can see that P is negative 2 and Q is negative 5, as simple as that. Now let us move on to the B part of question number 14. And here is the B part of question number 14. WXYZ is a parallelogram whose vertices are given as WXYZ. You can see their coordinates. We're asked to find the values of M and N. We're asked to find the unit vector in the direction of X, Y. Well, I think the best way is to draw the parallelogram. Parallelogram, you should know that opposite sides are equal and parallel. So, assuming we have a parallelogram like this, W has which coordinate? Negative 1, comma 1. X has m, comma n. Y has 5, comma negative 7. And z has 2, comma 4. You should know that these two are parallel. These two are also parallel. We're asked to find the values of m and n. That is the Roman 1 part. So you should know that vector WZ is equal to vector XY, or vector XW is equal to vector YZ. Different combinations, but I'm not going to apply that. I know that we can have a midpoint from X to Z or W to Y, and their midpoints must be the same. So how can we find the midpoint? This is what I mean by midpoint. You see this point of intersections between the two diagonals must be the same. All right, let me start with midpoint. Mid WY is equal to, let's add the x components together, negative 1 plus 5. Should I write everything? Okay. Negative 1 plus 5. You should divide that by 2, comma, 1 plus negative 7, or simply 1 minus 7. Also divide by 2. This is the midpoint, which is going to give us what? Negative 1 plus 5 will give us 4. Divide by 2 is 2, comma. This is negative 6. Divide by 2 is negative 3. So you can see this is the midpoint of WY. Now, what is the midpoint for the other direction? XZ. This is going to be m plus 2. M plus 2 divide by 2, comma, n plus 4 divide by 2. So what you should know is that this component must be equal to this component. That must be this. This implies that m plus 2 divided by 2 is equal to 2. Let's solve. Cross multiply, you have m plus 2 is equal to 4, which implies that what? M must be equal to 2. As you take 2 to the other side, it becomes negative 4 minus 2 is 2. Therefore, m is equal to 2. What about this one? N plus 4 divided by 2 must be equal to negative 3. Cross multiply, you have n plus 4 equal to negative 6, because 2 times negative 3 is negative 6. If you take this one to the other side, it becomes negative as well. So you have negative 4, negative 6, which is negative 10. And hence, n is equal to negative 10. We are done with the first one. We are asked to find the values of m and n, and hence, here they are. But I would like to use them subsequently, so permit me to bring them back, because this is where they are. M, comma, n. M is 2, right? Yeah, 2, comma, negative 10. So now let me clear this and go to Roman 2 part. Now, the second part, we are asked to find the unit vector in the direction of what? X, y. So we need to find xy first. What is going to be that vector x, xy? It is going to be what? The position vector y minus the position vector x. This is xy, so you take this component, you subtract this component. Because we are moving to this direction, it means that this minus this will give you that vector. All right. 5 minus, I'm going to do that directly. 5 minus 2 will give us 3. Minus 7 minus 10. It is going to be minus 7 plus 10, which is also 3. We are done with this one. Then we also need to find the magnitude of this vector. The magnitude is going to be this, right? This is the magnitude, which is going to be what? The square root of what? 3 squared plus 3 squared. This component, you take this one, you square that, you take the other one, you square that. This is going to give us 9 plus 9, which is 18, right? Because this is 9, this is 9, 18. And 18 is the same thing as 9 times 2. Square root of 9 is 3. So 3 is coming outside. 3 root 2. This is what we have. Now to compute for that unit vector x, y, it is going to be, what do we call it? Let me start with this one. It is going to be this divided by this. You can even write this formula, this divided by this. Let me write it. X, y, divided by the magnitude. All right. This is going to be what? This is 3, 3. 3, 3. Divide by this, which is 3 root 2. This is equal to 3 will cancel 3 because we are going to distribute, remember. 3 will cancel 3. We have 1 over root 2, comma. The same thing here, 1 over root 2. But you know in mathematics, this is not standard. Let's rationalize it. If you multiply the top and the bottom by root 2, it is going to be root 2 over 2. So root 2 over 2, comma, root 2 over 2. This is the unit vector in the direction of x, y. Yeah, we are done with question number 14. We are moving to the last question, which is question number 15.